Hi guys, it looks like some of us are still having trouble with limiting reagents, and then that goes into percent yield. So I'm going to do a problem again so you can see it, and maybe you can use this to help you do the problems on the test. So this problem says if 15 grams of nitrogen reacts with 15 grams of hydrogen, 10.5 grams of ammonia is produced. So what you'll notice about this problem is that I've got three numbers, which can be kind of confusing. I'm going to start by writing the equation because that will help me kind of organize and figure out what I have. So 15 grams of nitrogen. I remember nitrogen is one of those diatomics, so it has to be N2. Reacts with, so that's a plus sign, hydrogen. Hydrogen is also a diatomic, so it has to be H2. 10.5 grams of ammonia is produced. So that means I need an arrow because ammonia is my product. And then I have to know that ammonia is NH3, and you might have to go look that up. That's okay. It's just one of those compounds that's a common one. Once I have my equation, I need to balance. So 2 nitrogens, only 1 nitrogen. So I'm going to go ahead and put a 2 here to take care of that. Hydrogens, I have 2. Hydrogens, I have 6. So I need to go over here and put a 3. So my equation is done. It's balanced. Now I'm just going to put these numbers down here with this. I know I have 15.0 grams of nitrogen. I also have 15.0 grams of hydrogen. And then they told me that I have 10.5 grams of ammonia. So you can kind of see where those numbers go. The question, or the first thing we have to do here, if we are given amounts for both reactants, which we are, we have an amount of nitrogen and an amount of hydrogen, which one do we use? So in the problems we did earlier, there was just one amount given. You just used it, converted, done. The problem here is that you've got 2 amounts and you have to figure out which one to use. That's why we have to figure out our limiting reagent. So if you are given the amount of both reactants, you have a number in the problem for both reactants, you have to figure out which one is the limiting reagent. So step number 1 to do that, pick one of them. It does not matter which one. I always just pick the first one. So I'm going to choose the 15.0 grams of nitrogen. I'm going to start with that. And what I'm going to do is I'm going to convert this to the other reactant. I'm going to convert the nitrogen to hydrogen. And what I'm doing is I'm basically figuring out if I have 15 grams of nitrogen, how much hydrogen do I need to use up all of that? It's just like if I was making a sandwich and I knew that a sandwich was 2 pieces of bread and 1 piece of bologna. If I have 14 pieces of bread, I know I can use that 14 pieces of bread. I can convert and use my ratio for my sandwich. So I know that 2 pieces of bread for each sandwich, 1 piece of bologna. I know that I'm going to need 7 pieces of bologna. Okay? It's the same thing we're doing here. If I have 15 grams of nitrogen, I can use my ratios, my recipe, to figure out how much hydrogen I need, and then I'll do some comparing. So I'm going to set this up. I need to get to moles, so I'm going to do 28 grams of nitrogen on the bottom. N2, so 14 times 2 is 1 mole of nitrogen. Then I'm going to use my ratio, so I'm going to go up to my equation. I want to get rid of nitrogen, so I'm going to put 1 mole of nitrogen on the bottom. That's this guy. And I'm going to put 3 moles of H2 on top. And then last thing, I want to go back to grams. So I'm going to put 1 mole of hydrogen on the bottom, and a mole of hydrogen, H2, would be 2 grams. So now I can calculate 15 divided by 28 times 3 times 2. I got 3.21 grams of hydrogen are needed. So if I have 15 grams of nitrogen, I need 3.21 grams of hydrogen. Okay, this is where now, next step is to take this number that I just calculated and compare it to what was given in the problem. So if I go back to the problem said that I have 15.0 grams of hydrogen. I need 3.21 grams, so I'm going to have a whole bunch of extra. So that hydrogen, I only need 3.21 grams. I have 15. This is my excess reagent. Okay, I have extra of it. Hydrogen is my excess reagent. Well, if hydrogen is my excess reagent, I don't need to calculate. Automatically, the other one has to be your limiting. So my only other reactant is nitrogen. So nitrogen is my limiting reactant. Okay, sometimes you'll this one will be your limiting. It just depends. You just have to compare those two numbers. Now I know what to do as far as solving the last part of this, which is percent yield. Percent yield always, 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 always refers to product. So we are going to be looking at how much ammonia. We know how much they actually got when they did the experiment in the lab. We need to find what's called the theoretical yield, which is the amount that should be made on paper. If everything goes perfectly, this is the theoretical yield, is how much ammonia we should get. So we're going to do that by taking our limiting reactant amount from the problem, which is 15 grams of N2, and we are going to convert to product this time. We're going to convert to ammonia. So I'm going to do the same thing. I want to get into moles. So I'm going to put 28 grams of N2 on the bottom, 1 mole of N2 on top to get to moles. I'm going to convert now using my recipe. So I'm going to put 1 mole of N2 on the bottom. That's this guy again. I want to convert to ammonia though. So I'm going to put 2 moles of NH3 on top. And then same thing, I want to convert back to grams. So I'm going to put a mole of NH3 on the bottom. And I'm going to put 17 grams of NH3 on top. So that will get me what I call my theoretical yield. This is on paper. If everything goes perfect, everything reacts, this is how much ammonia we should get. And when I do that calculation, I get 18.2 grams of NH3 produced. Okay, that's what I should get. Now we know in a lab, and especially in a lab like ours, things don't go perfectly. And rarely do we get 100% yield. Rarely do we see the exact amount that we should get on paper. So what scientists often do is they calculate percent yield to see how close are we? Did we get close or are we way off? So this is my theoretical yield. This is what we should get according to what the work I did on paper. The last thing is to take that amount that they gave me in the problem, which is your actual yield. So they actually got 10.5 grams of NH3. Divide it by the theoretical, which is that 18.2 grams of NH3 that I just calculated. Multiply by 100, and I will get a percent yield, in this case, of 57.7%. Okay, so the biggest thing here is if you have a problem where you have two amounts for reactants given, if you have an amount for both reactants given in the problem, you have to figure out which one is the limiting. And the easiest way to do that is to take the first one and convert into the other, and then compare the numbers that you calculated with the number in the problem. That will help you determine limiting, and then you always, always, always go forward with any calculations using your limiting reactant. All right, if you have questions, let me know. Good luck.